Okay, we're going to talk here about continuous random variables. So this is supposed to help you with your homework in Chapter 6. So here we have a table of the heights of female students, and this is in inches, but the idea will work just as well. So 60 to less than 61, 61 to less than 62, 62 to less than 63, and so on. This is the number of people, number of female students that had heights in each of these intervals. And there were, I guess, a total of 5,000. And here we can do the relative frequency, which means 90 over 5,000. 170 over 5,000 is this number. So when we sum these up, we said we'll get 1. And this is a relative frequency distribution, so between 60 and 61, there was this percent. Between 64 and 65, there was this percent, and so on. And so we sort of smoothed out the line here. And then they say that in general, or more generally, we'll smooth out the line like this. And going back to this, you can see that if we look at what's the width of each one of these bars, it's 1. And the height was the probability. Go back to here. The height was the probability, so that, or the relative frequency, so that if you add up the areas of each of these, then you're going to get 1, because we said when we add up the frequencies, we get 1 here. And the area is going to be the relative frequency. The area is going to be the relative frequency, and when you add up the relative frequencies, I said frequency before, you're going to get 1. So what's the area of this bar? It's exactly the height, because the width is 1. So when you add up all the areas, you're going to get 1. So we say the probability that x assumes a value in any interval lies in the range between 0 and 1. And the total probability is 1. And so this is a smoothed out version, and this is called a continuous random variable. And we get the probability by looking at the area. So if you want to know the probability that x is between a and b, you look at the area underneath the curve. So the total area should be 1 or 100%. So the probability that x is between a and b is going to be the area under the curve. So if this was the curve and it was we wanted to know 65 to 68 inches, probability that x is between there, it would be the area under this curve. Then they say that the probability of any particular point is 0. So that's always a little bit puzzling, but the idea is that if you don't make it 0, then how many numbers are there, say, on this interval, or going back to the particular example, like how many numbers are there between 65 and 68? Well, if you're talking about decimal numbers, you could have 65.1, 65.11, 65.111. So in other words, there's an infinite number of numbers between here and here. And if you let them all be more than 0, then when you add them all up, you're not going to get 1. And we had to have, at most, that you would get 1, but that won't happen. So we say that the probability of any particular point cannot be, basically, generally speaking, cannot be more than 0. But intervals have non-zero, have bigger than 0 probabilities. And again, the probability in an interval is going to be the area under the curve, the shaded area here in green. So here is some more data between 25 and 30, 30 and 35. And then if you graph this, you might get something like this. and then they say you can change it to look like that. And some more observations. So if the graph looks something like this, then it might look kind of like what we call a normal curve. But this is not exactly the same as a normal curve. But this part here, from here over to here, does look like a normal curve. So the idea of a normal curve is that the total area under the curve is 1. The curve is symmetric, and the two tails of the curve extend indefinitely. So this kind of picture here. So the curve is symmetric, and the mean will be right in the center, and it will have some kind of standard deviation as well, and it goes on forever in both directions. The shaded area is 1. It's symmetric, so if you look at the middle, then to the left and to the right, the areas are the same, 0.5. Each of the two shaded areas is very close to 0, but not equal to 0. So when you go out far away from the center, and by far away here they mean 3 standard deviations from the center, then the area under here is small, but not 0. And then we have this picture, which shows us that there's not just a single normal curve, but it really represents all kind of a general, like what they say, a family of curves. So these are all called normal curves, and in fact, all of these normal curves are all centered at 50. So the mean for all of these curves is 50, but they're spread out in different ways. So the light blue one is more spread out. It's flatter, so it's more spread out than the dark blue one in the middle, and the green one is kind of in the middle in terms of how spread out it is. So the more spread out a curve is, like the light blue one here, it means that you're more likely to get values out here and over here than you would be with this dark blue one. This one, the dark blue one, the curve is lower as you move out than the light blue one. That means the probability is less as you move out. So that means you're not likely to get large values in this direction or in this direction. So that means that since you're not likely to get values that are far away from the center, that means that it's not the data is not so spread out. So that I'm talking about for the dark blue one. So that means the standard deviation is smaller than for the light blue one, and you can see that the standard deviation might be 5 for the dark blue one and 16 for the light blue one. Now these all have the same standard deviation. They're all spread out about the same, but they're not centered at the same place. So you can have all the same standard deviations, but centered at different places. And then so we said that there are a bunch of different normal curves. These are all normal curves, and these are all normal curves. So we talk about specifically one of these, the one that's centered at 0. Now, these are not centered at 0, and these are not centered at 0, but we could easily center one at 0. And then the one that has standard deviation of 1, now this has standard deviation of 2, that one had 5, 10, and 15, and 16, but we can imagine there's one that has standard deviation of 1. So the curve that's centered at 0 and has standard deviation of 1 has a special name, and that's called the standard normal distribution. So it's centered at 0, mu is 0, and the standard deviation is 1. So it might look like that. And then we talk about the z values. So I'll come back to this in the next video.